So welcome to our last session of Calculus for Kids. Khalid won't be here tonight. He had another commitment that unexpectedly came up that wasn't easy to replace, so he asked me to finish this off and wrap it up for us this evening. So our plan tonight is just simply to get your feedback on what happened over the last few weeks, how it went, ask questions of each other, share our successes, get any support or encouragement we need. Basically, our goal is that you leave tonight going, yep, I'm good. I've got this. I can use that forum and play to my heart's content. So my first question is, how did it go? And what did you try out? And what experiences did you have? I know we're all busy. I managed like 2 Sparks.
Well, should I start?
Sure, go ahead.
Okay, yeah, we made a point in the past couple of days of trying to do these right before the meeting, and actually it's been really good. Yeah. They didn't always come off the way I anticipated, but the kids had fun. So I'll give you guys an example. There was that topography one, and up until recently I had the things on me. The topographic maps thing.
Yes,
you know
I like that one. Yep, I do.
And so let me show you what the kids did. It was very funny. So I got them like a big pack of the foam, and I'm like, okay, we're going to be learning about topographic maps. And basically I got out the phone, and they went nuts.
That's not a surprise. Oh, wow. You did go nuts at your house. That's awesome.
It was like 3 hours worth of them like having fun creating this, I don't even know, it's like islands of pirates and stuff. And they didn't really follow the directions. And I would sort of gently try to, like this one, I was like, oh, it's kind of sticking out. It's not really layered, you know?
Mm-hmm.
This one was my volcano. We did volcanoes and stuff. But they were having fun, and we were talking about it, and we looked up a topographic map of our neighborhood, which was super interesting.
I've never thought to do it with our own neighborhood. That's really
cool. There's like some big database service. So if you Google topographic map and, you know, your town or your zip code or whatever, you can zoom right in. So that was neat. And, you know, I think they got a lot out of it, even though they weren't really following the rules. Does that make sense?
That's why we say make your own math, right?
Yeah.
Do your own thing with it. We found a site I'm putting in the chat box. I think it's a .com. It's Compass Dude. And I really like it because he teaches kids how to read topographical maps with little tiny challenges like, would you rather take route A or route B? And it's the best explanation of actually reading a topographical map that I've found for kids. So that was kind of our extension. It was really fun. I love the topo maps because it's one of those times when the math actually, how did Maria once say it? Like the math literally mirrors what happens in reality. You know, when you do it on your hand and you draw the lines, they literally spread apart. Or if you get your kids to build an island out of foam and you slide it over and slope it, the spaces really grow. So it's a really good activity for kids to see that math can model what's happening in the real world. And that we use these symbols of math and maps and things to model life. It's abstract, but a little less abstract than some of the other things.
No, I like that. And I like the idea of using that word model a lot. You know what I mean?
Yeah.
That's good.
So who else wants to, what was your favorite Spark that you tried, even if it was one you did in class? How did it go at any of the other homes? I have a visitor. Nina's baby's sleeping, so she needs to be quiet. So she's going to put it into the chat. My baby has a cold, so she's on my lap showing you her princess. Yeah, those are your princesses. So Rachel or Cheryl, how did it go with your Sparks at your house?
Good.
Do you have a favorite?
There we go. Yeah. We had a lot of fun with it. We started the dimensions one, and I don't know how we even got onto this, but we started it and then we never actually started it because we got distracted and we started, it was my 5-year-old who did it. She started making spirals. And so then we got out some graph paper. Let me see if this will catch. We got out graph paper and we drew a line along one side and we made spirals that like only got bigger by 1 unit each time. And then we drew like spirals that get bigger by like by 1 and then by 2 and then by 3 and then by 4 and then my anyway, we ended up making a bunch of spirals and my kids started recommending patterns. And so then these are the different patterns that they recommended. And then we decided if you were a bug in the middle of the page and you had to get off of it, what pattern would you want to use? And so we had pattern of +1 and then we called it a singled or like a tree trunk. You know, like everything is always the same. 1 is it gets bigger by 1 and then 2 and then 3 and then 4 and then 5 and 1 it doubles and then we did Fibonacci and then we did squared. And anyway, that was really fun. It was fun because they knew they were off topic and so they felt special.
That's really cool. I like how you said that. They made their own math and they found out we went our own way. We're not even following the Spark, and I love that they liked that. They felt like mathematicians. That's wonderful. That's
and it was
cool.
It was fun to put the spirals over the top of each other too. And then you could see like that spiral doesn't mean one thing, which they like.
That is a really fun one where you can watch them grow. And I can see Cindy's brain's like, I could animate that on PowerPoint.
Actually, can I share something?
Sure.
So we watched, I guess because we had all these YouTube videos going, I like the suggestions for the videos.
Yeah.
Working for us. And then we were watching like cute animal videos this morning, but it suggested a math video, right? So we watched this, you know, Vi Hart.
Yeah, I know her.
The
Yeah.
doodler girl, right? She's so amazing. We watched this 3-part video, but it relates to your spirals, where she explained why you see the Fibonacci sequence in all these plants.
Yeah.
And she explained it really well. Like I've never heard such a good explanation. And I've taken plant development and all this stuff. So, but she talks about those different kinds of spirals. So you might look at that.
Yeah, I'm ready to get done.
She talks so fast, though, I have to watch every video 5 times.
Yeah.
To understand what she was saying. So, yeah, that's really neat. That's really fun.
She did a really good job with the biology, too. That impressed me. She didn't just get the math right. I can say she got the biology right.
That's good, because Cindy's the biology lady. So that's impressive. It's Vi Hart, Nina. Have you seen hers? It's just VI. It's her to type it around my microphone here.
Like Vi Hart. And it was a 3-part Fibonacci numbers video sequence, but then it related to plant phyllotaxy, but I don't think she used that word.
Okay, thanks. That's really neat. I love that it went off on its own. Like so far, even at Cindy's house, it went off on its own. I found when I got the craft foam out and did the topography with my kids, and we've had the craft foam for a while, same thing. My son's like, I don't want to make one. He has had 2 volcanoes at the top, and he was like, no, Mom, slide it over here. I want a bigger meadow. And they're just doing their own thing, and it was fun. And we still talked about sliding it around and turning it into a map and taking a picture, and it was enjoyable. That one they never go like you think they're gonna go, but it's just really fun when they go somewhere. That's what I'm getting used to. That for being a structured mom, it's taken a while. So let's see, Cheryl or Amy, did you have any particular sparks that just really worked for your family that took you off in weird directions or were just really fun?
Hi, this is Cheryl. I worked with the dimensions, and I'm a little different. I'm not I don't have a family. My family's grown. I'm a grandma. And my background includes Montessori, so I look for connections when I'm learning anything. It just happens automatically. And looking at dimensions, I quickly reflected on Montessori unit beads, and 10 bars, and 100 squares, and 1,000 cubes. And I began to, let's see, among some of the sensorial materials that Montessori has, there are red rods there are 10 red rods. They're 2.5 by 2.5 centimeters with different lengths, 10, 20, 30, 40, 50, 60, 70, 80, 90. And we would do what we called extensions to some of these materials. And there was a question, can you assemble a curved surface out of straight lines? And well, yes, you can. And we did it in training, and it's marvelous to look at, and it's just kind of like, wow. But nobody ever talked about, hey, this is calculus. And I wish that somebody would have, because there are some surprises. I can try and show a picture of these red rods, but first I have to do this. And so these are 10 red rods, and you can see how it makes
how you got a curve. It reminds me of the string art. You guys ever remember doing the string stuff? You know, you have the nails that make this, and you go from this one to that one, and it makes that nice, beautiful parabolic curve that I didn't know was math. I just thought it was fun. That's really neat, Cheryl. Thanks for sharing that. I love Montessori. A couple of my kids are in a Montessori school.
Good to hear.
Anyone else want to share your experiences that's able? I know Nina can't. String art is so cool. That idea of straight things making curved things. And the dot and the line, have you read that book? Norton Jester's The Dot and the Line?
There was a video.
There's a video, yeah. We posted that on one of the Sparks. There's also it's a little tiny book. I love the video. I love to read the book to my kids with such drama, and my husband always walks through the room cracking up at the jokes that the kids don't get in the story. But anyway, so if you haven't read that one before, I'll grab it off my shelf and show you. So was there anything on a Spark that didn't go very well?
Can you all hear me? I'm doing
Yeah.
Oh, okay. I'm trying to get settled here. I've got a low battery too, but you know what? First of all, I have to own, we didn't have a ton of time to really kind of dive in to a lot of them, but also I'm a really structured person too. And also I don't have this great math background. So what happened for us was I looked at every single one of the Sparks and I was like, I have no clue what any of these are about or how any of these relate to math. And I watched, I did both of the videos, and I kind of, I did the Play-Doh, and after the Play-Doh, I was like, I have no idea how this is calculus or how this is math. So one day I just said, okay, I'm just going to dive in. I'm just going to, throw all of my worries to the wind, and we're just going to do the one. And we watched the dot and the line video, and, my kids are 9 and 12, and they were, we sat and we watched it and kind of laughed at it. And then we did the sticks, and everybody kind of did it. And then we were kind of like, well, what does this all mean? And what did we just do? And, well, we have no clue. So we cleaned it all up and put it away, and that was it. And so, then I kind of just kept saying, well, maybe I ought to get another one out and do another one. And I kept looking at them, and then I was like, it's just the first one just didn't really go all that well. And so we just never got around to doing any of the other ones. So I was kind of frustrated with all that.
I totally understand. I don't have a background in calculus. I mean, I have, high school math, but I didn't have calculus. I think I've been in this class now 4 times, 5 times.
Yeah.
And there are still times, like even with the topography, where I don't know the procedural math that goes with it, so it's harder to make a connection.
Right.
And harder to feel like did I do math today with my kids
Right.
versus other things. So I don't know that I have any great advice for you other than, like with your kids and their ages being a little bit older, the purpose of the sparks is, when Kelly talks about it's just an intuitive understanding of something, it's going to come back later. Cindy used a term in an email or this during the course that she sent me. It's an investment. That really helped me. Like, I may not understand what the path will look like later. I'm trying that people that get calculus are saying that if my kids can, for example, understand how things could be sliced up differently and put back together, and a few little things that later on they're going to be able to go, I did that once with my mom. That's like this. Now, having said that, I keep bugging Khaled. I'm like, would you write the textbook that actually teaches you calculus and uses your analogies so I don't have to put the analogies together from somebody else's textbook?
I wanted the connection made. Like I somehow wanted it like some sort of aha moment, like, oh, that's how this all fits together. And so it wasn't very satisfying. He used an analogy of, you may not have ever made spaghetti before, but you follow the instructions and you're going to make spaghetti. But for me, it was more like, you're going to follow the instructions and you have no idea what you made. And when you finish it, you still have no idea what you made.
You've never had spaghetti before, so you don't know if it's spaghetti or not.
Yeah. So that, we may do some more of them, but that was my biggest feedback, was I would love to just kind of like figure out how this all kind of translates to math, just make it a little more satisfying.
Mm-hmm. I know it's kind of tough because getting, like when you do something where you can go like multiplication explorers, we all as adults understand it. You're like, you're having all these really cool aha moments that you wish you had had when you were 8, but guess what? Your 8-year-old's not having them.
Right.
We are. And so we feel like this has at least been my experience. I feel like, oh, this is going to be so good when they're older because I just got all these things I never understood before about fractals or this or that, or I saw this. But when I don't have that experience, then actually I'm experiencing the exact same thing my kids have with all the sparks.
So we're all lost together.
Yeah. Well, my kids are like, there's no math in that. Where's the math in that game, Mom? And it's okay with me when I'm like, there's math in there and I can see it. We'll get to it later. But when I don't know where the math is, then I feel I'm in the same boat as your kids. I've just had to trust Maria and Khalid that there's calculus in there. And then the more I've studied calculus, just the bits and pieces, I'm like, oh, okay, this is calculus, but I still don't know exactly how. So it's fun for me to hear people in these classes who are like, that's what that means. That's what that means. And they're having that wonderful, satisfying experience. Right. And I'm like, I still don't know what you're talking about.
Yeah, I'm glad you get it. Yeah.
Yeah. So I would say keep trying some of the sparks for fun and telling your kids, I don't know where the math is in this. I'm not really sure, but they promised us that if we try calculus, that this will help us understand calculus and integrals and differentials and different things like that. So should we try it? And if they hate it, don't do it. It's right. That's not the point, but it's in there. But you and I are on a little bit more of a take it on faith basis than people who've taken calculus before.
Yeah.
So
okay.
Thanks for being honest and for sharing that, because it's different for every house.
Yeah.
And we've had a couple people join too. Anybody else that had a not so successful spark or anything to share? Yeah, Rachel, go ahead.
I want to say something on what Amy had said as a way that I've been thinking about this whole process, that I feel like math is taught, and I've been bringing it to the analogy of reading. I have a 5-year-old and she's, sounding out words, and that, we all love sitting and reading those books. And I feel like math is taught traditionally in this way where we teach kids, you have to learn your letters first, and then you have to sound out pat, cat, mat, and you have to be able to, construct words and then read sentences and paragraphs, and we build this whole thing. And only once you can read a chapter book will we ever read a chapter book to you. Like, if we only gave them the stories that they could read themselves, if we never read to them until they learned their letters, I also have a 2-year-old, and, you sit and read the board books to him. But what if I just only said his letters to him all the time and never gave him a story until he could understand what they were to get there, to connect those two pieces, the story and then the grammar and the sentence structure and everything that goes into the mechanics of what reading is versus what a story is. And I feel like math is the same way, but we've taught math by teaching our kids letters and then simple words, and then by the time they get to high school, they're just so bored with it and they don't ever see its application. That's the thing you always hear in life is like, this doesn't matter. And I think we just failed to ever tell them the story, because all math is based in reality. It has there is a reality that's behind it that has nothing to do with numbers. It's just that numbers are our way of measuring and quantifying and communicating that reality. So to me, the sparks were the piece that, like, reading to my children who don't know how to read yet. And so they can't point out the adjective and they can't even pick out the letters, but we're reading a story. So we're having an experience of where this brings us. And that's how I was seeing the sparks, that we were together looking at space and shape and form and, dividing and reassembling, and we were just experiencing something. And then later, as we grow, we add in the numbers in the same way that you experience a story, and then as you grow, you add in the letters and the grammar. That was my experience with it when I kind of went, what's this? How does this relate? I don't know. That was how I explained it to myself. Anyway, there.
Thanks, Rachel. I appreciate that. I know for me too, I've had to learn how to ask questions. So when I'm doing stuff with these sparks that I'm like, I don't know the math per se. I just know supposedly it's like integrating, right? But I've never done an integral on paper ever. And so I'll think, but I've learned to ask my kids what they're thinking. And then even if I don't understand the math, if I can say, why did you build it that way? Can you explain to me what you did with those shapes? What do you think would happen if we tried this? Oh, well, that's not what the spark said. You did it a different way. That's really cool. Why did you try it that way? What do you like about it? Maria always likes to ask kids, what do you like about it? Or do you like what you created? And it's interesting to get in their heads and see their thought processes. So I found a site that it's not calculus for kids, but it's called Would You Rather? And I had my 9-year-old and 7-year-old, he had a question, would you rather have a 1.5 ounce bag of Sun Chips and share it with one friend, or would you rather have a 7 ounce bag of Sun Chips and share it with 7 of your friends? And then you have to justify your answer with math. And we were doing that for math class yesterday. My son and he's 9, my daughter's 7. And I knew they couldn't do the math, but they could figure out the problem. So we started talking, and I said, well, how are we going to figure this out? And they're like, I don't know. And I realized, oh my goodness, we need to work on problem solving here a little bit. So we talked through, what do we need to know? What information do we need? What does ounces mean? And after half an hour, we'd gone through a lot of information, and I had the calculator do the actual math for them when we found out, and they couldn't comprehend ounces. So we said, okay, let's just make up that 15 chips weigh an ounce. And they were like, okay, we can work with chips. So we made that up, and we did a conversion, and we did all this mathy stuff, which I recognize as math because, you've done that kind of math. They didn't. They were just trying to figure out which bag of chips to buy and which way to split it up. But what was so interesting to me was, I know they can't do that math. Like, I can't hand them that problem tomorrow and they'll suddenly whip out division and be like, oh yes, I know exactly how to calculate the unit value of the ounces. That they can't do that. But now they can think about how to solve that kind of a problem. That was what and they're only this much better at it, because I realized, oh no, we need to do way more of these before they'll even know where to start. So even if I had taught them division skills, they would still have stared at that problem and gone, I don't know. So it was I'm just sharing it because for me, I was like, oh, eye-opening. So if you can use Sparks for nothing else but to see how your kids think, you see gaps there that are, regardless of calculus or algebra, really are helpful for you as a mom and for them too, to explain and defend their answers and quantify it or just whatever. That's kind of how I use them a lot lately. So that was a big blob of information, but so any other stories, feedback? I did see in the chat, I wanted to point out, we had that there's NT. I don't know your name, but that's how you logged in. They did a lot with the topographical maps as well, and even built one of the Hawaii island that they visited. I'm jealous. So anyway, and then there's a recommendation of a Mysteries of Math show from Nova. Another. Oh, go ahead, Cindy.
Can I describe that? So we ended up watching all these math shows recently, and what's funny is the kids were gripped by this. I swear they're really into this because Nova, they're such geniuses in making things accessible, you know?
Mm-hmm.
And it got at, like what you were saying, Rachel, this sort of storytelling aspect, you know, of math and why it's interesting. And they one of the people they interviewed was the guy who put the Mars lander on the moon. And he talked about gravity and isn't it amazing that math works so well throughout the universe, even in distant galaxies and all that stuff. And so they had sort of the beauty of math in there in a really intuitive way. And then what's funny is they touched on this thing about the Fibonacci sequence in all these fruits and vegetables or, you know, plants. And then but they left it hanging. And then we stumbled on that Vi-Hart thing later and we got the answer, and I was so thrilled to get a good answer. But can I just touch on what Amy said, because honestly that was niggling at me too. I was like, because I have taken a lot of calculus, but it was a long time ago, and I was like, okay, some of them I get and some of them I didn't get, or it was still fuzzy. I was trying to think back to the problems I used to do. So it was kind of funny. If you Google easy calculus problems, like I was just trying to remind myself of what they look like, you get these things that are not easy, right? And I'm like, oh, great, that's not helpful. And then I found these calculus instructors complaining about how confused their students were. And it reminded me that so much of calculus gets bogged down in like canceling terms and all these dumb rules and sine, cosine stuff. And you kind of get bogged down in the logistics of doing it. And so in a way, I like that these are like intuitive aspects of it, that even when you're taking calculus, you don't see it because you're too caught up trying to figure out what the rules are for canceling terms, you know? But like one thing, like that thing about, I was trying to get this across to my kids with that one activity, the idea that, oh, does this work? Hold on. So I got the straight lines bit, and I feel like, oh yeah, that's a really good fundamental principle, right? That relates to like instantaneous velocity, right? So the idea is that if there's something that's changing velocity, it seems like a hard problem, but you can figure it out by drawing a line where the slope of the graph is at that instant, okay? And so it's useful to, like, the mental preparation for that concept that they'll do later is the idea that you can put a whole bunch of lines on a curve and they will express the curve. So the idea that you can make a curved shape out of straight lines is sort of the intuitive mental preparation for being able to calculate instantaneous velocity.
Okay, I'm going to throw something out here, and if I'm not mistaken, you make those lines infinitely small is really what
That's
you're
right.
doing, right?
Yeah.
Yeah, I'm going to, someday I will understand calculus.
See, I was thinking we should get just like, if you grew up with one of those string art owls in your house, you would be told, because I tell you, we spent a lot of time looking at string art, and now we bought the little nails, and we're totally going to do this because they're amazing, right? These people make all these beautiful curvy things with nothing but straight lines, right? So if you just lived with something like that, you would have, no learning gap to getting that concept. And that's one less barrier that you would have to understanding how to do that. You know what I mean? Because at least that little chunk of it would make intuitive sense.
Yeah, I think the challenge is that some of our brains can make the connection between the string art and the calculus more easily on our own. And then if our instructor's not, I really don't think some instructors intuitively understand calculus, to be honest, not in the same way. And so somebody bridges the gap. And I think part of what Amy's saying and is what I feel as a mom, like I want to be able to bridge that gap for my kids. I want them to like get it intuitively and then do a math problem and then know what question to ask for them to bring the two together. And that's still really difficult. If you don't know the math, you can't bridge the gap, and you can't always bridge the gap right away, which is why I loved your comment about it's an investment. Sometimes I think that I understand calculus or multiplication better because I'm 40 and not 8. Like it's just a matter of I'm not 8 years old anymore. My brain is a little bit more developed and they're not going to understand those things. So I love that there's just that aha moment where it does connect and it's so satisfying, like Amy said. And so when you can't get it, it's a little bit frustrating. And I know that feeling. So
yeah. I'll say I love that analogy about reading to our kids. I love reading aloud to my kids, and even before they knew how to read, I would love doing that. And I think the frustration for me comes because I cannot do the equivalent for them in math. Do you see what I'm saying? Because I don't know how to read aloud math to them because I don't understand. I took an entire college level calculus course, and it wasn't until last year in New York City we went to the Museum of Math, and there was like a display about what calculus actually is. And I read this display and it explained it, and I was like,
that's what I did.
That's what I did for a whole year in college. I had no idea. And so, I love that idea of showing them the math. And, I guess I can do that with the Sparks, but like you said, Shelley, it's like maybe, I'm being read aloud to at the same time that they are, and I still have no idea how to read.
A little bit. I think there's a little bit of that feeling. And I think also it would be like reading to your children in a language that you don't speak. And you know that they will be so much better off than you. And you know they're learning stuff, but you still have this it's really uncomfortable to be like, I don't know all these words. What if they ask me what that is? And I say, I don't know. Like it's so much easier if you have the English version right next to you or you're reading in English. But even if you read to your children a really difficult classic, all of us learn by reading. I remember Jim Turley's Read Aloud Handbook. You should read to your kids even when they're 17, which I'm not that good at that, but because he says you can always read ahead of their vocabulary. So it's maybe the same thing in math. As long as we're always just a little bit ahead of their understanding, and maybe we go back. And it's like you said, though, you did calculus and you didn't get it. You don't want that for your kids. So if you're laying a foundation now, maybe together when they open their calculus book, the two of you together will be like, oh, I get it.
Remember when. Yeah.
And
absolutely.
And you'll have words and intuitive words to be like, oh, that's like that craft stick thing we did. Remember? Hey, you remember when we got out the mandolin and we sliced up all the fruit one day when you returned?
Yeah, absolutely.
That's what we're hoping will happen. Your kids are already better at Spanish than you. Mine had Spanish neighbors. They speak more than me. So I thought I would share this. I wasn't planning to, so I'm going to do a quick screen share. So I did decide to tackle calculus like I don't like that word, the final level of understanding of calculus, the stuff that looks like what we think of math. And I was working on limits. I've made it through all of one chapter of Life of Fred. And I had to have Maria and Khalid help me get through my one chapter of Life of Fred. And this is the equation that we were graphing. And I was trying to figure out the limit. And I couldn't get it until Maria had me play around in a Desmos graphing calculator. I don't know if any of you have used that before. It's desmos.com. I'm pretty sure that was the one anyway. There's another one too. And so it was graphing it for me. And then when I saw it visually, then limits completely made sense. I was like, oh, that's all they're talking about. But as Maria and I played around, she kept having me change the top and the bottom. And so you see here, there's x to the fourth and x to the third and x to the second power. And we were talking about the strength of the powers. And as we played around on Desmos, like as you increased the power on the top or the bottom, that graph shape like overpowered the other shape. You could literally see them morphing. So we would I graphed y equals x to the fourth plus 5 and y equals x to the third plus 6x squared separately, and then did this division and just like watched how they morphed and moved. And even though I wasn't doing the graphing, which is fine by me because I hated that in high school, it was like they were moving and interacting, these equations. And I was too lazy. I told my husband, who's a poet, I said, I'm too lazy to put these into complete sentences, so I wrote a poem. And he didn't think that was very funny. But this is what came out of that experience. And I just wanted to share it with you because even if there's no math, maybe there will be this interesting emotional reaction and math will just simply not be so scary anymore. So here is my poem about graphing lines. It says, graphing lines coming together to show the tension and grace of their powers. The exponents pulling, forming an entirely new shape. The struggle of powers births an entirely new creation with a beauty, grace, and wonder all its own. Graceful, fluid, moving, now toward infinity, now away, now toward zero, now away, but it can never arrive. There are limits to its powers, curves, and grace, even empty spaces at times. What a beautiful pattern of numbers, space, and time. What lovely art and joy, graphing lines. I know I didn't feel that way about graphing in high school. And so the only reason I'm sharing it is just because sometimes I'm starting to be like, what if that's the only thing my daughter experiences, but she could never graph them without Desmos? Can I be okay with that? And I think I can, because it's a different way of experiencing math. And this was a really emotional experience for me, not like in a sad, weepy way, but like it was like art. And I'd never experienced that with math before. And I think that's the other reason it came out in a poem. It just kind of had to. And so, yeah, real mathematicians use software anyway. We were just happy to have graphing calculators back in the 90s. So anyway, there's just, my love of math has become, yeah, I really want to tackle calculus, but I want to feel that feeling. And that feeling didn't come from solving the problem. It came from watching things interact. Anyway, so I just thought I would share that with you. Maybe that's a little bit inspiring too. Oh, sure, Cheryl. I'll send it out after class. I posted it on on the Natural Math blog a while ago, and she told me to submit it for publication in a math anthology book or something, and I cracked up and I told, if I get published for that, I will die laughing. But anyway, so it was a pretty neat experience. It was fun. Are there any other questions, concerns? Do you feel like, oh yeah, I could keep playing with Sparks now, and I kind of have a direction? You might try another one, Amy. Maybe. Okay. I have learned a lot. Every time I do this, I learn so much. I don't always get into the forum between classes as much as I'd like. I'm a normal mother like the rest of us, but I learned a lot about PowerPoint from Cindy, and she's going to be teaching a class coming up on PowerPoint and the cool things, Maria calls it lapware, that you can do with your kids to watch that slices of time and some really neat activities with your children to play around with math that I promise you'll see the math. So we'll let you know when that happens, but that's coming too. The last thing I like to do is just ask if there's other particular feedback on the course ways. Oh, what resources for building those equations? It's called the Desmos calculator, desmos.com. You can just put in, it's really actually pretty fun because you can just put in equations and go, what if x is squared? What if x is cubed? What if x is to the fourth? What if I divide it by 2? What if I divide it by 1? And you get all these weird looking equations with dead spots and where it can't be that because it's over 0. So you have this beautiful line with just skips, and then they go weird directions. And it's really fun with the kids because you can be like, what happened? They go, whoa, that's not what I expected at all. And you're like, yeah, me neither. I don't know why it did that. Why did it do that? And if they're older, you can talk about, well, it can't divide anything by 0. So there's this hole in the equation. But that's about as smart as I am with equations. Sorry, the sun's coming through my window, so I'm squinting. So yeah, it's called Desmos. I was just trying to learn calculus, actually. And that's where the equation came from. The fourth dimension. I can't even go there. I'm not.
My kids were really into that Flatland movie.
Oh, that's pretty awesome, isn't it?
I was astounded, and we ended up playing and talking a lot about this fourth dimension. I mean, I'm not saying I understand it, but it was fun for them, you know?
Mm-hmm.
I had to buy the movie, and it was kind of pricey, but it was totally worth it, actually, because it was fun for them. They got a kick out of it.
I think
they want the next one. They want the sequel.
Tell them to write it.
My kids loved that fourth dimension movie.
Did they?
And it was just like, you can't even understand it, you know. But they loved it and watched it multiple times. And then we were talking about how he was explaining a fourth dimension to people who really only understand 3 on something that's 2 dimensions, like on a computer screen. Like, he's not even explaining it in 3D. He's explaining it in 2, you know? So you're like twice removed. We thought that was fun.
That's really cool. Dimensions are so, like, they baffle my brain. I have a hard time with spatial things. I finally realized that's like my weak point in any math is spatial stuff. Don't ask me to build things or quilt. It will look bad. So, Cheryl, you put in the links way up about what you did with the book, A Beginner's Guide to Constructing the Universe. There it is. I'm going to grab your link right now.
Yeah, you mentioned the book, and I worked up a project because I thought so many connects. When I read the book, I thought I could bring this to young kids, and it was fun. I'm no longer in the classroom, but I still feel passionately about it. And
that's really cool. I'm going to spend time there. That book was kind of my introduction to, math isn't the stuff I do at school.
Me too. Me too.
It was amazing, that book. I can't recommend it highly enough because it's just, I learned things about, so I love studying anything, but I studied a little bit of Hebrew too. And in the Hebrew language, the letters are numbers. There's not a separate digit and stuff like that. And so gematria, and the symbolism of numbers, and that combined with my own personal beliefs, it just was like, whoa, I was seeing things everywhere. And it was just so cool. We had great fun using our compass to birth the shapes. And it was neat because, I don't know, I always wondered, how do they build these amazing things without a ruler? You know, they had a straight edge, but no ruler, no amazing tools. And I love to tell my kids, we think we're so smart, but look what they did back then. And how did they figure out how to make a perfect octagon or polyhedron with a compass and a straight edge, and how particular you had to be? Because my kids had trouble, we had trouble making those on paper. So it's another approach. And we tried building things. Oh, we had a blast. Yeah, we're talking about A Beginner's Guide to Constructing the Universe. And very symbolic math. And seeing it in architecture and things. It was fun when we moved. About 6 months ago, we moved cities 3 hours away from where we used to be. We drove by, I think it's a Lutheran church. We drove by and my daughter said, "That looks just like Notre Dame. And it's got the same architecture, and it has this shape and that shape." And just everything starts to open up when you can see patterns around you, even if you can't do equations, I guess is what I'm getting at. Yeah, I love that. So thank you, Cheryl. Anything else that you guys discovered that you want to share, like any other tangents you went on or great resources that were helpful?
I found a quote that I'm going to post. So,
what is it?
Everything we study is just an imaginative representation in our mind. This means that we have the possibility of reconstruction that allows our intelligence to go far beyond the limits of our sensorial impression. And that just, it was kind of serendipitous that I found that quote. And it just, I don't know, it speaks to me. And I would think that I'm looking for people who love calculus if that rings for them.
Mm-hmm. Interesting. It's just a representation, and math really is just another way of representing things. Like words are a way of representing sounds from letters and sounds we make with our mouths, and not even a very good way to represent some of our sounds in English. If you talk to speech pathologists, we need a whole lot more letters.
But the whole idea of the possibility of reconstruction is like that. Working with the Sparks, I would keep asking myself about any object. How would a 3D printer build it? How would it grow in nature? And how would you make it with crafts? And it's just, I don't know, all those things, reconstructing things and wondering if answers to questions we have are really right under our nose. We just have to reconstruct things. That I wonder about that.
It's an interesting take on solving problems, isn't it? I know that the first time I was preparing this course with Maria, we were trying Sparks, just her and myself, and we were trying to figure out how they'd work. And we said we're going to make a carrot, and I made a carrot out of yarn. And I remember feeling so dumb, like, this is not math. What is going to happen with this? And nothing is going to happen with this. But pretty soon, my husband, who has had calculus, was in the room, and he's also got a degree in horticulture. And we were trying to figure out, like, well, if I wrapped the carrot this way, and it actually started to kind of look like a carrot, and would it work with other things besides string? No, string really did work pretty well because carrots kind of grow that way. And then we were like, do they grow that way? And we were Googling, oh yeah, they do kind of grow that way. They're kind of like a tree. They grow from the inside out. Well, then how come they have these little notches? And we were asking questions. And it was so funny, the three of us having this conversation, trying to reconstruct a carrot out of string, like you were saying, and the connections we were making. And, my husband, having had a little more experience in horticulture and in calculus, was like, I never thought. He was having the aha moment that we all want, Amy. He was having that payday, and I thought it was funny because I'm just playing on the ground with string, thinking, I don't get it. And so you never know what will come out of things. Mandalas and some of those things. If you use GeoGebra to draw your mandalas, and you can keep going forever and ever and ever and ever and ever, and keep zooming in for infinity. It's really fun what you can do with computers and with your kids, and try reconstructing digitally or with crafts or, with PowerPoint. I've just seen so many different ways of doing things. It's just been really fun to be involved in all of this. So thank you all for your time, your input, your thoughts, your enthusiasm. Do you have any feedback on the class that you want to share at this point? You're always welcome to just email it to me on the structure, if it was what you expected or not, or anything that would have helped you. We hope bugging you a couple times throughout was helpful. We were told that would be helpful because we forget to go to forums too. So is there anything that would have made it a better experience for you that you can think of?
So I put this in the chat, but I think for people who do want to connect it to real calculus, I think like a one-page thing with actual calculus problem examples and kind of like pinpointing the little intellectual concept that we're preparing the student for, like that thing about the lines or integrating, and just making that real explicit. Because yeah, as the sort of director of the activity, I like to know what I'm trying to nurture the kids to recognize. You know what I mean?
Yep, I totally get that. And I think we've heard that before too. And we're just sitting around waiting for Cully to do it. So we are honestly working on getting that on the Sparks. Even if you just had math words a little bit more like, no, this is integration. Yeah, okay, we get that. But no, this a little bit more specific, like you said, a little more explicit help. Even if I just knew what to Google, it would help. So that's something we are working on, especially for the kids as they hit like the 12, 13, and they can handle some math. Sometimes it's just fun to show them that's the equation. I don't know how to solve it, but that's what the equation would be to do what you're doing. And that's kind of cool to a kid too, depending. Sometimes that freaks them out and other times they love it.
Yeah, it's not so crazy. Like a preview, like even what you showed, that this crazy looking set of letters makes this shape.
Mm-hmm.
Like if there was like a preview of Yeah. I can see that being a helpful thing. You know,
Yeah.
takes the scariness out of it.
Gives you, like you said, you kind of know where what your port is that you're steering the ship toward, and that floundering feeling maybe goes a little bit like, oh, okay, there really is math and it looks like this, and even though I can't solve that problem, I'm okay with that. I know this is what it is.
And can I share something that I had to discover for myself, which I should have known better? So like I discovered as we were going through them that I needed to do, so this is my mandala. This is my 5-year-old's. She turned it into a sweet little card. And this is my 7-year-old's. And I decided I'm going to always do my own alongside them, because then I don't micromanage them. I'm doing mine, right? And I can make mine illustrate the concept we talked about like how if you do the same decoration on an inner circle, there's less of it than on an outer circle, because the outer circle has added more area, right?
Mm-hmm.
So mine, I could show them the concept and I felt like I did my job, and then I could let them do their thing however they wanted. So they could make their islands all lopsided or whatever, but my island, I made sure it could show the steep and the shallow thing, you know what I mean? And at one point, I'm like, oh, you're making the islands wrong. And they're like, we don't care. We're just having fun. And I'm like, okay, touche. I shouldn't be taking away the fun from them. So that was my strategy for making myself butt out of their fun to some degree.
You must play and have your own fun. And I like playing dumb and be like, I wonder what'll happen if I push my island over. And and then they'll try pushing theirs over. And that can lead to some really interesting conversations. Why doesn't mine look like yours? Well, yours is built differently. So how, and then you can kind of go from there. But that's a good strategy. Play with them. Well, and if you're not willing to do it, my kids, kids are totally, they can detect you're doing this to make me learn something any day. So if you're not willing to do it, why should they do it? And so, it is fun. I think, the activity, I sent it out 2 weeks ago. Did you guys see the one about circumference and making rice? Did you get a chance to read that one? That was a desperate, I have these girls going, why? Very frustrated. Why? No, it can't be true. No, why? Why would the string always be the same amount no matter the size of the circle? And I'm going, I don't know. Let me think for a minute, And then when it dawned on me, rice is like that, because it's the only ratio I use on a regular basis at home is making rice. It's always 1 to 2. And when I said it to these girls who struggle with math in the typical sense, they really do. I know that because I teach them in other contexts. When I said, well, if you need 24 cups of rice or 2, it doesn't matter. It's still 1 part of rice to 2 parts of water. Then that clicked for them. Then they could believe it. And it was interesting, the magic of that draw a circle and go a little bit bigger, and the awe kind of goes away a little bit when you can apply it to something concrete. So it changes from this magic trick to, oh, I get it now. Now I can be the magician. But I had to, and my students had to connect it to something we do every day, because we can't imagine measuring the earth, but we've all made rice. And so it really helped me to see. And again, it's that weird thing of I can do the math with pi. I've done it for years. I understand that pi is 3.14. I thought I got it. And then I did this and I'm like, it's a ratio. How did I not ever catch that before? I don't know. But, something just sinks into one person's brain that doesn't. And you keep revisiting it. And then you're like, oh, I get this even better. And then I want my kids to have all that instantaneously downloaded into their heads. And it doesn't work that way. They have to kind of go through the same experience. And I think that's the other challenge as natural math people, is to let our children have the same privilege of experiencing and exploring and discovering that we've had. And knowing that some of it will come with maturity too, but we're investing and laying an awesome foundation. And it's just fun, even when it doesn't work right. At least you're still building awesome memories with your kids. And math is a fun thing you did as a family. I think if nothing else, that's a really huge thing to give your children and your grandchildren and your students. So anyway, well, it is just about 7, and I don't want to keep you here just because of the clock. So if you don't have anything else, I will let you go. But if you think of anything, please email either reach.out@naturalmath.com or email me, shelleyrnash@gmail. I'll send you a PDF of my graphing poem just for coming to class. And you can do what you will with it. It's in the Creative Commons. So thank you everyone so much. It was very fun. I really enjoyed getting to know you and hearing your stories, and look forward to more.